Hi there, in this video we are going to see floating on grid system, benefits and challenges in a floating on grid operation by industries with captive power plant, CPP. Now as you can see in this figure, I have shown the captive power plant and a cement plant for an example. However, a similar case can also be with steel or for that matter any other plants. So this combined together forms an industry, and then this shows the connection, and this picture is represented as a grid. When an industry is connected with the grid, then it can have three modes of operations in a synchronized mode. So on the other hand, there is also island mode where the grid is disconnected, so which we are not going to discuss. So generally it is recommended and it is a best practice to be connected with the grid on synchronized mode in order for the plant and the industry to have a stability in case of any load fluctuations or etc. Now in grid synchronized mode there are three operations: export mode, import mode and floating on grid mode. Now in export mode, as we can see, the export mode, what happens is the captive power plant which generates PG is higher than the cement plant requirement, which is the consumption in green color. So in this scenario, the industry has an agreement with the utility wherein it will be paid for the export amount of the kilowatt hour it does. So and thereby, so on a fixed rate, so they have an agreement that for example maybe 10 megawatt or 100 megawatt or etc. will be exported to the grid based on the capacity and the agreement with the utility. I have mentioned this as an intentional export by the plant because the plant decides to export power based on the agreement with the system. So this is to be noted. While the import operation, the plant actually decides to import power from the grid, so that's why it's called intentional import by the plant. So this happens whenever the captive power plant has some kind of maintenance, or maybe the plant capacity of this captive power plant is not sufficient to supply all the power of the cement plant. So on these cases, as you can see, the red color one, which is showing as an import power. So this is and also this is being regulated by the maximum demand agreement that the industry has with the utility authorities. In floating grid operation, the plant neither wants to export nor import, but still does both when connected with the grid for stability, which means the plant do not have any agreement with the utility, so anything that it exports will not be paid back, and whenever it imports based on the maximum demand of the plant, what happens is the import charges for the every unit will be done as per the tariff of the utility. On this case, what happens is, even though the captive power plant has sufficient capacity to support the entire plant, still there will be an exchange because of the variations in the cement plant. So as you can see, the red and the blue represents import and export respectively. Now the challenges in this case is the export power is wasted on the grid because this is not paid by the utility. On the other hand, the import power from the grid due to the load variations, which cannot be supplied by the CPP, again this is an excessive cost to the plant because this power is more expensive than the CPP power. Solution using customized BESS, battery energy storage system. BESS operation for optimizing the import-export in floating grid operations with CPP. Now the problems with floating on grid operations is the import happens because of the load variations, even though the CPP capacity is greater than the consumption, as we discussed. Similarly, the export happens due to the load variations, that is because of the transients. Now what are the transient cases? Now case 1, when power generated is greater than the power consumed on a transient condition, the system actually exports power even though it is not going to be paid. On case 2, when the generated power is lesser than the consumption, automatically the synchronized grid will draw power from the grid side. Now we will see them in detail. Now solution using customized BESS, as we have seen. The case 1, excess import is stored in the BESS, that is battery energy storage system, when the power generated PG is greater than power consumed or required power in the by the plant. Now as you can see, by using a BESS and also a custom converter and taking a feedback from the main 132 kV or 220 kV, now as you can see, it is showing whenever the requirement is in export mode, then instead of doing an export, that export power will be consumed by this excess energy bank battery, and as you can see, it is getting charged. Now the question is, in normal cases, whenever this battery energy storage system it's available, now how and where it is being used is it's only for the stability in the grid level. Now with the same thing, we have to customize it to use it to our advantage of saving and using the excess energy by the cement plant with the captive power plant. Now in this scenario, in case 1, as we have seen, in summary what we can understand is, whenever in transient conditions the export power, the power is excess, now that excess power will be consumed by this excess energy bank in the system. Now in case 2, excess import is supplied from the BESS when power generated is lesser than the power consumed or required power. Now in this case, as you can see, this is a transient condition. We have to understand that in floating grid condition, so whenever the kilowatt is being generated, now that feedback will be given to the customized converter, and thereby, so based on the availability of the storage unit, it will discharge the required amount of the power or the maximum ability of its capacity to the plant, and thereby avoiding the import. As you can see, there is no power is being imported. So this is case 2. Now let's combine both of them and then see together. Now this is a complete unit, so wherein, so on a full scale operation, what will happen is the battery energy storage system with the customized ability and a separate algorithm, what it will do is, so you can see here the feedback is taken from the main PCC, which is point of common coupling. So plus denotes import, and minus denotes export, and 0 denotes no import or export. Now these feedback will be given to the control system, and that control system drives this custom made converter, which is actually charging or discharging this battery unit. Now in this scenario, whenever there is an excess kilowatt, that will be charged, and whenever there is a requirement of kilowatt from the grid, and that will be supplied by the battery energy storage system. This is an ideal condition. Based on its availability, this system will actually exchange power between the plant and the grid, so and thereby making it a very efficient system, saving enormous amount of kilowatt hour, and thereby economics into the industry. Now, summaries and solution. Requirement of a new innovative solution for the problem. As I have already mentioned, the requirement of this system is customized based on the feasibility study that we have to conduct in the plant, and this custom converter will take feedback from the 132 kV or 220 kV, which is the PCC of this combined industry by cement and the captive power plant together. Now just to look at it in a very simple manner, the algorithm that has to be designed should be customized to the requirement of the plant based on the variations and the feasibility study that will be and have to be conducted. Requires an intelligent real-time communication in PLL, phase lock loop, and building of BMS, battery management system, for the rapid charge and discharge cycles with suitable medium. So I hope this clarifies the advantages and disadvantages of floating grid system, and the solution to remove the disadvantage by connecting it with the customized BESS. Thank you.